second order differential equations. So the one which we are trying now is second order differential equation. So we have finished first order differential equation. This would be the second order differential equations. So this has much more things to be there. Okay, we will see what is second order differential equation. This is the chapter. Yeah, this is like a second part of the chapter in the same differential equation. The second part. Okay. Now, let us understand first of all what is second order, how does it come, and all those things one by one we will see. Okay. Now, linear differential equation of the second order. Linear differential equation of the second order. Second order can be written in the form y double dash plus p of x y dash plus q of x y is equal to r of x. This is the general form of second order differential equation which is linear in y. Correct, because y double dash does not have square, y dash does not have square, y does not have square. So it is linear. Okay, this is a linear differential equation of the second order. Okay. Now here, if r of x is equal to 0, then 1 reduces to y double dash plus p of x y dash plus q of x into y is equal to 0. And this equation 2 and reduces to this. Okay. Equation 2 represents is called homogeneous equation. Homogeneous differential equation of the second order. Homogeneous differential equation of the second order. If r of x is not equal to 0, the differential equation 1 is non-homogeneous. So we have seen one homogeneous and non-homogeneous in first order differential equation. That is in a different context. This is in a different context. That is separate. This is separate. Depending on the context, you have to tell what is it. Okay. So this is it. Okay. Now, what do you mean by solution of this differential equation? Solution means, have you written this down till here, everyone? So this forms the notes. Okay. Online students, have you written this down? Not finished? Please write it.
Yes, sir.
Nikhilesh Badlin. Yeah. ಹೇಳಿದ್ದು ನಾನು ಮೆಸೇಜ್ ಮಾಡಿದ್ದೇನೆ ಅವನಿಗೆ. ನಾನು ಇದರ ಲಿಂಕ್ ಮೆಸೇಜ್ ಮಾಡಿದ್ದೇನೆ ವಾಟ್ಸಪ್ ಅಲ್ಲಿ. ಇದನ್ನು ಕಳಿಸಿದ್ದೇನೆ. ಅಲ್ವಾ? ಇಲ್ಲಾಂದ್ರೆ ಚೀಪ್ ಆಗ್ತದೆ ಮಾರ. ನಾವೊಂದು ಅವರಿಗೆ ಬೇಕಾಗಿ ಅವ್ರು ಬರಬೇಕು ವಿನ ನಾವಾಗಿ ಪುಷ್ ಮಾಡಬಾರ್ದು. ಒಂದ್ಸತಿ ಹೇಳ್ಬೋದು, ಎರಡು ಸತಿ ಹೇಳ್ಬೋದು, ಹೇಳ್ಬೋದು. ಅದು ಮಾಡಿದ್ದೇನೆ, ಮೆಸೇಜ್ ಮಾಡಿದ್ದೇನೆ ಅಷ್ಟೇ. ಹಾ, ಮೆಸೇಜ್ ಮಾಡಿದ್ದೇನೆ, ನೋಡ್ಲಿಲ್ಲ ಅವನು. ಅವನದು ಮೊಬೈಲ್ ಎಲ್ಲೋ ಇದೆ, ಡಿಡ್ ನಾಟ್ ರೀಚ್ ಹಿಮ್. ಐ ಹ್ಯಾವ್ ಮೇಲ್ಡ್ ಹಿಮ್ ಆಲ್ಸೋ. ಐ ಹ್ಯಾವ್ ಟೋಲ್ಡ್ ಹಿಮ್ ಇಟ್ ಇಸ್ ಅಟ್ 4 o'clock. So should we remind him again because he is not seen? Let us give him a missed call. He is not in the range even. So it's up to him. It's his prerogative. Correct. Now next. Now another point here. Another point. Now let us see about homogeneous equation. Let us get with homogeneous differential equation of second order. Homogeneous differential equation of the second order. Now let us see what do you mean by solution. Okay, a function y is equal to f of x is solution of equation 2 if it satisfies equation 2. If it satisfies equation 2, correct? What do you mean by that? For example, let us take example. What is meant by that example? Okay. Y is equal to e power x is a solution. I'll take example 1. Is a solution to the differential equation. Y power x is a solution to the differential equation y double dash minus y is equal to 0. Why? Because dy by dx is equal to e power x and d square y by dx square is also e power x. Correct? Now substituting into the differential equation we get, that means y double dash minus y is equal to, this will apply here, e power x, sorry, this one, and then this one you apply here, minus e power x, that is equal to. Make sense? When you apply this over here, you get the solution. Correct? So e power x is solution of a differential equation. Example 2. Example 2. Y is equal to e power minus x is also a solution to the differential equation y double dash minus y is equal to 0. So let us check. Y dash is equal to minus e power minus x and y double dash is equal to plus e power minus x. So both we are checking. Correct? So y dash is equal to minus e power minus x, y double dash is equal to plus e power minus x. Let us substitute that over here. When you substitute that, you get y double dash. Yes, please. Who's that? Nikhilesh ji, I have started. Okay, so you can start. Yeah. So we have started with the differential equations. Okay. So we have started with what is second order differential equation, and then we have started with explaining what is meant by the solution. Okay. So if I say one second, you're not sure about how loud you are. Okay. Okay. So here y is equal to e power x is a solution to the differential equation y double dash minus y is equal to 0. Why? Because dy by dx is equal to e power x and d square y by dx square is equal to e power x. And when you substitute into this differential equation, you get it as 0. Similar way, y is equal to e power minus x is also the solution to the differential equation y double dash minus y is equal to 0. Why? When we take y dash, you get minus e power minus x, y double dash plus e power minus x. So when you substitute that, you get this as minus of e power minus x, and that becomes equal to 0. Now let us see the example 3. Have you written this down? I hope you write it along with this because this is easy. Now, whenever things are easy, why we are doing easy things? To get the concept clear. Okay. When we have to understand concepts, we have to do easy problems. That time we understand concepts, and then to check the skills, we have to go towards difficulty. Now, if you try to say difficult only when you do very in the sense to understand the concept, you go with difficulty, you will not get the concept. Okay, done. Now, example 3, I will write it here only. Example 3, check y is equal to e power x minus e power minus x or plus e power minus x. Check whether, okay, check whether, write down whether, check whether y is equal to e power x plus e power minus x is a solution, to y double dash minus y is equal to 0. Check it there and see whether it is a solution. So you will see that is also a solution. Okay, next, example 4. Let us go with example 4. Let us check y is equal to, let us check whether e power x plus e power minus x is solution to y double dash, and it is, you have checked it. Check it out, you will see it is a solution. Now check whether e power x minus e power minus x is equal to y, or y is equal to this, I'm sorry, y is equal to e power plus x plus minus e power minus x is a solution. You will see that this is also a solution to the same y double dash minus y is equal to 0. You will see this is also a solution. Okay, check it out fast and tell me. Okay, because these are easy things, it has been done a lot of times, but this is only to strengthen your concept. It's like a Shivaji when he was winning over big forts. If he goes and attacks the biggest fort, then what will happen? He will face defeat. He has to first capture the smaller forts and get the strength over that, increase the strength, then attack the bigger fort. Similar way, smaller things we will do first. Okay, so don't feel this one that, sir, what is this? This we know. It's easy. It's easy, I do agree. But there's one concept here. Okay. Next, check whether y is equal to a e power x plus b e power minus x is a solution to y double dash minus y is equal to 0, where a and b are real numbers. Where a and b are real numbers. See that it's also a solution. So what does that mean? That means there are two types here. Let us understand. Okay? It is a solution. You can write it down later on. If you want, you can check the solution later on. You will get it the same. It will cancel, and you will get it as 0. Okay. So now, what is the thing? What is that we are reading out of this? We are reading out that if y is equal to f of x is a solution of equation 2, is a solution of equation 2, and you know what is equation 2? Equation 2 is this homogeneous equation. This is equation 2. Getting that point? If y is equal to f of x is a solution to equation 2, and y is equal to g of x is also a solution, is a theorem. If y is equal to f of x is solution to 2, and y is equal to g of x is also a solution to 2, then any linear combination, or any linear combination. Okay, wait. Okay. If y is equal to f of x solution to 2, and y is equal to g of x is a solution to 2, and f of x and g of x are linearly independent. I'll tell you what are these things. Are linearly independent. Then I will tell you what is linearly independent. Okay, are linearly independent. Then any linear combination, any linear combination of f of x and g of x, f of x and g of x is a solution, to, you can take any number you can put, you will get it as solution. Okay. Now what do you mean by linearly independent? Linearly independent means f of x by g of x should not be equal to any real number. Should not be equal to any real number. Then it is linearly independent. Means what? F of x by g of x should return a function rather than a number. For example, if I have example, okay, sin x and 5 sin x, which is a combination, are linearly dependent. But sin x and cos x are linearly independent. Why? Sin x by cos x is equal to tan x, which is another function. Getting that point? So it is linearly independent. Exactly. It should not be a multiple of that. One should not be multiple of that. Okay. Even if it is a multiple, that will be the solution. But there is some more thing. Okay. If f of x and g of x are linearly independent, then any linear combination of f of x and g of x is also a solution. Actually, in this theorem, even though they are not linearly independent, also the linear combination will be this one. So this is not required. Okay, wait a minute. It's also a solution to 2. Just you cut this. This is purposefully we can do this. This is not required to be linearly independent. Even if it is not linearly independent, the linear combination of both of them will become a solution. For example, e power x and 5 e power x These two are not linearly independent. But e power x, wait, e power x plus 5 e power x is also a solution. You can see that. For this equation, e power x is a solution. 5 e power x is a solution. E power x and 5 e power x are linearly dependent. But e power x plus 5 e power x is a solution to that equation. So, for a linear combination of two functions to be a solution, it need not be linearly independent. I hope you get the point. Nikhilesh, are you getting it? Nikhilesh
Yes,
ji?
sir.
Okay.
Yes, sir.
Chetan, is it clear? Chetan ji, are you there?
Yes, sir. Yes, sir. Clear.
Siddhi, write this down. Write this down neatly. Notes has to be written neatly. Your handwritten notes matters a lot. करत करत अभ्यास ते जड़मति होत सुजान. It's very important to continuously study, continuously update. Abhyas is very important. So you have to write that and then cut. Don't think I have cut it so you will not write it. No, you have to write it. You have to write that and f of x and g of x are linearly independent. You have to write it. You have to put it in bracket and then cut it in your notes. Don't do like, sir, you have cut, so I will not write. No, no, it has to be written. Because you should know all the down page. You have to understand all the things which are there. This is what happens in any competitive exam. You have to know all the aspects of the things. Shall I proceed? No, you are writing. Please write. Exactly. I will tell you. I have not told you what is linear combination. I will tell you what is linear combination. Linear combination means suppose you have so e power x is one function. Sorry, f of x is one function and g of x is another function. You say a f of x plus b g of x. That is another function, which is a linear combination of all these two, where a and b are real numbers. Got the point? So I have told you what is linearly independent. I have not told you what is linear combination. I'll tell you. 1 by 5 is linearly dependent. Here I have told you what do you mean by linearly independence. I am not saying if it is linearly independent, linearly dependent, it will not be a solution. I did not say that. Okay, very important. Okay, so let us go next. Now, what do you mean by linear combination? Linear combination of a function f of x and another function g of x is given by linear combination f of x is given by, say, f g h of x is equal to a f of x plus b g of x, where a and b are real numbers. You have a linear combination. Now here one thing, I'm sorry. Let us do one thing. We will cut down this real like this. Purposefully, I said the real and then I cut it. Why? It can be complex numbers also. I will show you how it can be a complex numbers later on. So real you have to write and then you have to cut. You understand that? So while you write only, because you're doing mistakes, you're learning from the mistakes. You said real and you cut it. Because later on we are going to see complex numbers coming into picture there, where we use a combination of complex numbers also. Okay, so let us see. Okay, especially when it comes to sinusoidal functions. Okay, in vibrations we have something called when we can get into a place where you get the characteristic equation, the solutions are complex. So then you have to multiply by a complex number. So when you multiply by a complex number, you are having a complex numbers there as A and B. You got the point? So there, it's important to know that it can be a linear combination of that A and B can be complex numbers as well. I hope getting the point. So linear combination. Example. Now this is one of the. So example is uh, do you require example? No, I suppose, right? Linear. You need not, right? Because you have understood what is linear combination. To e power x and e power minus x, linear combination can be 5 e power x plus 3 e power minus x. It's a linear combination. Now, what do you mean by basis function? Basis solution. Let us see what is basis solution. Okay, two solutions, two solutions of differential equation of a differential equation of a differential equation, two solutions of a differential equation which are linearly independent, two solution of a differential equation which are linearly independent and can be used to form a general solution. Can be used to form the general solution is called basis solutions. Yes, solutions. It's called basis solutions. So if you say E's, then you should not have E's, you should have R. Are called basis solution. Or these solutions form the basis of the differential equation. Form the basis solutions of the differential equation. Means using these solutions, I can put general solutions. Just a second. Hello, sir. Namaste, sir. Heli, sir. Heli, sir. Heli, sir. ಇಲ್ಲ ಸರ್, ಈಗ ಇಲ್ಲ ಸರ್, ಏನು ಇಲ್ಲ ಸರ್. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಸರ್. Okay, fine. So two solutions of a differential equation are linearly independent and can be used to form a general solution are called basis solution, or these solutions form the basis of the differential equation. For example, now we will see what is general solution. We will see what is general solution. Linear combination of the basis solutions which represents all the basis solution, a linear combination of the basis solution linear combination of the basis solution which are uh, formed which are formed using arbitrary constants, using arbitrary constants and represent all the sets of solutions, all the sets of solution, or all the possibility of solutions, all the sets of solution, or all possibility of solutions is called a general solution. It's called a general solution. Hope you get the point. Next, let us see about particular solution. I hope you are able to relate. These are not something which is new to you. This is not. Only thing is that you have done everything. Now we are going on the top and we are seeing how the different things are. It is just like summarizing whatever we know. Correct? Okay. So, next. I hope you have written this down. Please write. Please write. I will give you. I'll give you everything. I will give you. I'll say next particular solution, and then I will give you all the things combined together with example which I have done with respect to e power with respect to y double dash minus y dash is equal to 0. Y double dash minus y is equal to 0. I will tell you what is meant by general solution, what is meant by particular solution, what is meant by basis solutions, and we will see this because this has to be understood first. What happens generally, only problems you do, you don't understand the basic theory, then what happens in exams like GATE, you get into trouble, you fall into trouble. Because they ask you the basics. You have seen how easy it is, no? I do a particular concept and then I give you the GATE problems. You are all doing it, I am not doing it, I am not solving it, or you are not feeling it as it is difficult. Why is that? GATE is a basic exam. It is not a tough exam, it's a basic exam. And you should not think too much there that it is very difficult. It is not at all difficult. Okay, it's very easy. Even 50 marks, scoring 50 marks in GATE is very easy. Okay, a person who does everything to the basics and understands everything, scoring 50 marks is easy. And 50 marks you can get into IITs. You can get MS into IIT, not MTech obviously. But if you have a quota, you can get it. Okay, so within sometimes I don't understand why the people who have quotas don't try GATE exam, because it's easier. 45-50 marks you get the best of the MTechs. You understand? Don't worry about whether it is right or wrong, all those things. Don't get into that. We have got some opportunities, let us utilize that. Correct? We should not feel anything about it. Okay, we have got an opportunity, let us try. Why not? There are so much of politicians who are taking so much of benefits. If you understand, let us give it back. The only thing is that when we are getting something, this one, let us give it back to the society. That should be the aim. Okay. Done. Next one. Now, another point over here is this. See, particular solution. Particular solution. Okay. The solution obtained. Solution obtained. The solution obtained by finding the exact values, by finding the exact values of the arbitrary constants the solution obtained by finding the exact values of the arbitrary constants of the general solution of the general solution. The solution obtained by finding the exact values of the arbitrary constants of the general solution using boundary condition using boundary condition or boundary conditions or initial conditions. Boundary conditions or initial conditions is called a particular solution. So what happens? This particular solution is particular to that condition. General solution is general. It can conform to a lot of things, whereas particular solution is for a particular condition, either boundary condition or initial conditions. You get the point? Is it? Now let us see example. For example, we will see an example. We had taken y is equal to solution of y is equal to or solution of y double dash minus y dash y is equal to 0. This was the example we took. We observed that, say, let us say this is star. Okay? We said that e power x and e power minus x are solution to star. Correct? Now we have to check whether it forms a basis solution or not. How do you check whether it forms a basis solution? We check it by seeing whether they are linearly independent or not. If they are linearly independent, they can form a basis solution. If they are linearly dependent, they cannot form a basis solution. Now let us check whether, I'll say y1 is equal to this and y2 is equal to this, right? Check whether y1 and y2 are linearly independent. How do you check that? Check what is y1 by y2. What is y1 by y2? E power x divided by e power minus x. What you get? E power 2x, which is a function, not a number. Which is a function and not a number. Hence, y1 and y2 are linearly independent and can form general solution, can form basis, I'll say can form basis of the general solution, for star, can form the basis of the general solution of star. So you have the basis. On basis of what you are giving the solution? On the basis of these two solutions. General statement, you say Indians are brown. On what basis did you say? You say this is brown, that is brown. So Indians are brown. But can you say Indians are brown always? No. The Chinese looking people there in Northeast, they are not brown. There are some people who are black. If you go to Gujarat, there are cities who are actually black in color. In the sense they are blacks, African blacks. They are Indians. Not Chennai. Chennai is It's similar to us. This is a wrong conception that Chennai people are black. No, it's not. Some of them are much fairer than you. No, that's a wrong thing. There is no African race in Chennai. Okay, Chennai people are black. I do agree. No, Chennai people are black. That also I don't agree. Because the same blackishness, even if you go to Bihar, if you go to UP, if you go to, even if you go to Rajasthan, such black people are there. Darker shade of brown, that's it. We have brownish people, we have darker shade of brown or lighter shade of brown. We have brown people. However, white we may say ourselves. Okay, we are all brown. Okay. See, you can say he is white, but he's not white, he's brown. Understand? So like that. Okay. Then you can say हम काले हैं तो क्या हुआ दिल वाले हैं. चलो done. Now next, have you written this down? Right. Chetan, did you get this till here?
Yes, sir.
Chetan, you attended this class before? Is this a repetition?
No. Second order I did.
Second order you did not attend, is it not?
Yeah.
Oh, very good. Siddhi, it's a repetition, but repetition is important. Okay. Because at that time, previous time, it was slow. Oh, sorry, it was fast. Okay. You are getting new thing here, is it not? Okay, good. So, can form basis of solution, start. Okay. Done. The next one. This is very, very important. Okay. So, what happens? The general solution of star can be I hope I have started recording. Yeah, I started recording. Good. Okay. So general solution of star can be y is equal to some arbitrary constant a into y1 plus b into y2, where y can be a into y1 is e power plus x plus b into e power minus x. Make sense? So this forms the general solution. This forms the general solution. Now we have to find the particular solution. To find the particular solution, there are two methods. One is you have to find the boundary conditions. You have to see what is the boundary condition, or you have to see what is the initial conditions. Two things are initial conditions and boundary condition. Okay. To determine the exact value of arbitrary constants a and b. To determine the exact value of the arbitrary constants a and b, we need to know the boundary condition or initial condition. We need to know either boundary condition or initial condition. When for a physical problem, boundary conditions are defined. Boundary conditions are defined. Such problem is called a boundary value problem. It's called the boundary value problem. And when for a physical problem, for a physical system, initial conditions are defined, are defined, such system, such a problem is called, we will write this as BVP, okay? Such a system is called initial value problem. Initial value problem, or IVP is called the initial value problem, IVP, BVP and IVP. Now I have told these things, but I have not explained you anything. I have just given you the definition. Let us understand what is boundary value problem and initial value problem. Both are important. Let us understand using a pendulum. Very, very basics. Okay. Very important. Very basics. If you understand the basics, then only we can understand something better. Is it not? Either called the boundary value problem or the initial value problem. Now let us understand. You write it down. Right? I'll give you sufficient time to write. Don't hurry. Write it neatly. Notes keeping is very important. Leave margins. Okay. Yeah. People forget to leave margins. Want to save paper. We have to save our time later on in when the during the final 2 months. We need to find that notes. It is very important to do documentation properly. Every around 5 or 6 pages, one topic you will make. I have told you how to do it. Is it not? What you have to make? You have to make put 3 pins to A4 size sheet paper. Always in A4 size sheet paper. Okay, like this. You have 3 pins here. 1, 2, 3. And to this you put a sellotape, so that when you read, you will not have a problem here. Okay, this will not hurt you. Sometimes some of the pins comes out. Is it not? It hurts. And some people have a habit of their hands and legs won't stop. Sometimes some pen part goes into the mouth. Okay, you can observe their pen and all those things, and then you can see. Okay, I'm referring to one single person here who is ignoring it. Okay, fine. Okay. Yes, he did not understand now. Now he understood. Okay, fine. You see how everybody's pen talk, then you'll understand. And now it's fine. Yeah, now it's fine. Okay. So, but sometimes, okay, because when you think, no, you will not know where your hand, legs, and everything goes. Okay, so maybe you should not hurt. So put a sellotape from here to here, a blue or a green or a yellow sellotape. You get a colored yellow sellotape that you put. That looks nice also. When you read, also you feel like taking it out and reading it. Okay, so it's very important. And similar way, whenever some formulas are known, put a formula sheet. So one uh, uh, file should be there. Get this type of file. Okay, file should be there. Inside that, there should be at least 10 to 15 these sheet packets. That would be very nice. Okay, and holding it like this also nice. You hold it this way, then you remove this. You take it. You read it. It's like you feel you're professional rather than a student. Okay, you have a lot of files. You feel like professionals. You are taking files. You are not taking books. Okay. See the feel you will have. Okay. Fine. Next. Now let us look at about boundary value problem. Now we will take the same example, or yeah, we will take the same example. So we have defined, say, this is say y, this is say x, and then what is the equation we have? Equation is y double dash minus y dash is equal to 0. This is the differential equation, right? The differential equation start. What is the general solution? General solution is a e power x plus b e power minus x. Now I can say a point here, say x and y, say x is equal to 2, y is equal to 1. It's one boundary. Another boundary, I'll put it here, arbitrary I'll put it. Okay, because this refers to the actual case. Okay, I'm saying this solution, the solution of this passes through 2, 1 and 3, 4. Let us so let us see whether this is applicable here. Why? How do we do that? You find first, for first condition, when x is equal to 2, y is equal to 1. So you put a e square plus b e power minus 2 is equal to 1. First thing, you know e power 1 and e power minus 2, you know. Then when x is equal to 3, y is equal to 4. So what you get, a e cube plus b e power minus 3 is equal to 4. So what are we doing? This is a number, this is a number, this is a number, this is a number. These two are numbers. These two are equations which are not linearly dependent. These are mutually exclusive. You understand? That means you multiply this with some number, you will not get this. If you get that, then there are no solutions, is it not? Getting that point? So these two solutions, so equation 1 and equation 2, solve 1 and 2 to find 1 and 2 to find the arbitrary constants. This is boundary value problem. I'll give you one more example. I'll give you one more realistic example of boundary value problem. Okay. The problem is a stone being thrown. Stone being thrown from a particular place. Let us see the boundary value problem of this. Okay. Better now? Done? No, write it down, write it down. Next, let us see initial value. Slow and steady. I am going very, very slow here. Purposefully going slow. Because when concepts are done, even if you spend some more time, it's not a problem. This is one thing which is missing in most of the educational institutions. They go very fast and they think that students have to do it. But it's very difficult for a student to do these things. Even after we tell all those things, there is missing parts. Again, when it is repeated, the things become better. We should cater to the slowest learners. In IIT, there is a joke that in the classes, they will give a plus b is equal to 1 plus 2, 1 plus 1 is equal to 2. In the class, very easy questions. You will feel that, oh, it's so easy. But in the exams, you get the real difficulty. The real difficult one is there in the exams. But for that, the preparation is not done enough. Okay. So the students who have intrinsic intelligence, they do it. I'm not saying they don't do it, they do it. Okay. But the students who are not able to do it will fall flat. They will lose their full confidence. I've seen a lot of people doing that. Not that they are bad, but they're slow learners. That's it. They're slow learners. But they can do a lot of changes. Okay, so next. There are a lot of possibilities. Okay, done. Now let us take an example. Let us take a differential equation. The differential equation of a falling stone. A stone falling due to gravity. What is the differential equation? Yes, tell me. You asked the question. A stone falling due to gravity. What is the differential equation? Differential equation is d square y by dt square is equal to minus g. That's a differential equation. So now let us integrate that. When you integrate that, you get dy by dt is equal to minus g into t plus a constant. Let us write it as c1. Then I can use another one. I can integrate again. Integrate again. Integrate again, and you will find y is equal to minus gt square by 2. I have taken simple example purposefully because we are understanding the concept. No use of making it complicated. See, the most simple thing that can come is falling stone. Correct? Now this is the solution. This y is equal to gt square minus c plus c1t plus c2 is the solution to the differential equation. This is the differential equation. So the solution to the differential equation is this. How many constants are there? Two constants, two arbitrary constants actually. So what is this? This is the general solution. Now here in this case, there's nothing called basis and all those things. It's only one which has two differential equations, two constants. Is it not? You have two constants. If you want to say what is the basis of that, it can be gt square by 2 and t. These are the two solutions. Can I have it there like that? No, is it not? Because gt is no, you can have it because t square by 2 is one solution and t is another solution. These are linearly independent solutions. Because you divide one by the other, you get a function t. You don't get a constant. So combining two linearly independent solutions, we have got a general solution. Okay. Now here, this general solution, we'll ignore this for a bit. Okay. So in this general solution which is given, how to find out C1 and C2? Let me say at time t is equal to 0. Y was 10 meters. And at t is equal to 3 seconds, or let us say, okay, 100 meters. Let us put it as a bit bigger. Okay, 100 meters. So to understand with the realistic thing also here, 100 meters. And at t is equal to 3, y was 50 meters. 100 meters and 50 meters. Now, applying this here, we can find the solution. Now we can see y is equal to 100 is equal to minus g into 0 by 2 plus c1 into 0 plus c2. So you got c2 is equal to 100. And then to find the c1, we have y is equal to 50 is equal to minus g by 2, t square is 3 square plus c1, we do not know what is the answer for that, c1 into 3 square plus C2, which is 100. So using this, I will put G is 9.81, put G is equal to 10. Okay, take G is equal to 10. Take G is equal to 10. So if I take G is equal to 10, taking G is equal to 10, then I can find C1. Find C1 and tell me what is C1. Fast. Tell me what is C1. What did you get? Huh? 31.6 you got C1? No, do it properly and tell me. It's just an algebra, man. So it is, okay, I'll do it. Okay, so it is minus 50. Minus 50 is equal to minus 10 by 2, 5 into 3 square. Correct, 5 into 3 square plus C1 into 3 square. So 9 you can take it outside here. So you can write minus 5 into 5 into 9 is you go here 45. So you will get minus 5. You understand? And here you get C1 is equal to minus 5 by 9. Now this means C1 is equal to minus 5 by 9. So we have found the solution. C1 into not 3 square, I'm sorry. So 5 by 3, I'm sorry. Not 3 square, I'm sorry students. C1 into 3, 5 by 3, minus 5 by 3 C1. Correct? Agreed? Do a simple this one.
T square by 2 can be taken like the basis.
Basis.
But if you take that, shouldn't both that independent?
That can be done.
No, shouldn't it be the solution of that independent?
It will be. I will tell you. We can frame this one also as y is equal to C1 into T square plus C2 into T. Minus 5 by 3 is it? Not 5 by 3. Let us tell, okay, let us do this, okay, because T square is also a solution of this, okay, because C1 into G, here you see here, this one can also form the solution. If you see T square when you put, okay, let us write that out later on, okay, you'll get some other function, okay, you'll get some other thing, T square, when you say, we'll say GT, instead of that, let us use G into T square is also a solution. G into T is also a solution. You get the point? Okay, let us understand that. Now just hold on. Okay. So now this is how we do it in general. And what do we get here? Let us understand it further. So what do we get? What is a particular solution for this? Particular solution is y is equal to minus g by 2. G by 2 is 5. I will write 5. 5 t square minus 5 t square. Then minus 5 by 3 into t plus 100. This is a solution. Got the point? This is one way we can form the solution. There is another way also you can form the solution. Let us see how. All the possibilities we will check. All the possibilities. We will not leave anything. Write it down nicely. This is one way we get the solution. Now what does that mean? This also means something else. In the falling stone, one thing what happens here, I'll tell that. Okay, see here, this particular one can be equivalent to saying V is equal to minus AT plus U. So C1, what we had, is actually the initial velocity. So this stone, depending on this boundary conditions, has an initial velocity which is equal to minus 5 by 3. Means what is already falling with the velocity. This is positive direction. We have taken minus g here. So what is it? It is already falling with a particular velocity, which is having a velocity of minus 5.3. It is not falling from west. Getting the point? Sridevi, I hope you are understanding it. Or no, it's becoming difficult. It's becoming difficult. Okay. Let us understand again. See here. What we know, a stone is falling. At time t is equal to 0. When we are seeing, it's 100 meters. We don't know its velocity. But after some time, after t is equal to 3 seconds, I'm seeing it 50 meters. That's what we have seen. Those are the boundary conditions. What is the equation, governing equation? That acceleration is minus g. We have integrated it. We have got this. Got it? Again integrating, we have got this. These are arbitrary constants. How do we find arbitrary constants? We find arbitrary constants using the boundary conditions. I hope you get the point. So by seeing the boundary conditions, we know what is this dy by dt velocity. When t is equal to 0, c1. C1 is the initial velocity. T is equal to 0 means what? Initial velocity. Just by knowing the boundary condition and knowing the governing equation, what did we know? We know how the system works. And we know what are the conditions now. Based on that, I can find anything. Same thing is in the case of vibratory system, your fluid mechanics system. You know how it works and you know how it is. It is like seeing whether rise is properly proper or not. You understand? It's like measuring something. It's measurement. You know how rice boils. Okay. So you know after some time rice will boil. You seeing that you can get. You know how much this is kept. How much flame is kept, and you can speculate because you know more the flame, more the speed, something like that. You know how the governing thing is there. You know how it works, and you know the conditions. If a person knows how it works, it's not enough. Okay, always I say, if you want to understand differential equations, you can go to the kitchen. Because I've been in the kitchen today, so I know it. Okay. So what is happening here is you know how it works. You know how it works means you know the differential equation. You know the conditions. That means boundary condition or initial conditions. Then you know everything about it. Yeah. Okay. Done. So now understood now. Now are you comfortable with this? You have written this down. Okay. Now next point over here. Next very important point. Okay. Now the same thing here can be told with say d square y by dt square. This is one way we have to done is equal to minus g is the equation. Had I used y is equal to say for example t square as that, okay, minus gt square as a solution. Had I used y is equal to minus gt square as a solution, I would have got it, is it not? What would I have got? I have got this as see, when you differentiate it once, y dash is what? Y dot I will use because with the time it is minus 2g into t. Y double dot would be equal to minus 2g. So this is not proper. I should use this as gt square by 2. So let me use this. So one solution is y is equal to minus gt square by 2. Other solution I will use is y is equal to. What is other solution I can use to make it so? Can I use t? No, I cannot use t. Why can't I use t? If I use t, g is equal to gt. If I use, then what will happen? Uh, it will go as 0, correct, which is not proper. So it is t square only is a solution, is it not? So we cannot have two solutions here. There are ways in doing that. Now we are stuck here. Okay, we are stuck here. We know one basis solution. We do not know the other basis solution. Okay, one solution is known, but we cannot form the basis here. Now, next we will see a way in which we can form the basis when one solution is known. We know one solution, how to form the basis to find the other solution. That method we will do tomorrow. Okay, so that we can find, and then we can write y1 and y2, two solutions we can find. This for tomorrow. You have to remind me this. I want another y2 which is independent from this but satisfies this equation. GT will not happen, it goes to 0. Correct. Do we get it? G square we can use. Let us see. Okay, so we do not know now. Let us keep in mind we do not know, but there is a way to find it. You can discuss on that. Huh? Huh. But that doesn't satisfy this equation, no. See what happens. Y2 satisfies this equation, but y1 if you use gt, what is y dash g? What is y double dash? 0. So tomorrow you have to remind me that when we know a basis, I'm going to do that anyhow. Okay, but we will come to this and we will find the solution. Got it? Let us open up our minds and we will try it out. Is that clear? Make sense? Okay. Next, let us see initial value problem. Next one, the last one, initial value. I will just introduce you to this, then we will continue this in the next class. Okay. So initial value problem means when I am throwing a stone up, when I am throwing a stone initially, I know it's at, say, or we will put it in x and y. Okay, let us say this is x, this is 1. So at a point, if you know, at a point x is equal to x1, y is equal to y1, and at a point, at the same point x is equal to x1, dy by dt is equal to y2 dash, y2 dot, some number. So what you are having? You are having at the same point, but we are having a number and a rate, number and a slope, value and a slope. That is called initial value. You are at the same position, x is equal to x1. At the same position, you have the value of that function and the slope of that function. Then it is initial value problem. We are not going to the other point. We are at the same point. Make sense? So, in the initial value problem, we know initial value problem. We know the value. We know the value and slope of a function at a location X. I'm not using very mathematical things because if a mathematical professor sees these things being told, he will say this is not there, this is not correct, that is not correct. He will say. But the thing is that we have to understand we are a mechanical engineers. So we should know how much we know. We are worried about application. So we are understanding mathematics in terms of applications. And this is more than enough, or in fact very much enough for Git. Okay, so we will see the example can be if I'm throwing a stone, I know its position, okay, at t is equal to 0, and I know the velocity at t is equal to 0. Velocity is dy by dt, correct? We'll stop it here, students. We will discuss about this in tomorrow's class. Okay.